Hello students, and welcome back to another session in our study on trigonometry. I want to thank you for volunteering to watch this required mandatory video here for you. Last time we talked about, we reviewed a little bit about sine and cosine on the unit circle, those common angles. Then we introduced tangent, and today I'm going to start off with reviewing tangent, and then we're going to talk about some of the other trig ratios there, the reciprocal ratios. So I want you to pause the video and try to do this like in less than, a minute or two. All 6 of these. So pause it, try it out. Alright, so I trust that you paused it and gave it a try. Remember yesterday when we talked about tangent, we said there are only so many possibilities you can get for tangent with these common angles. You can get 0, you can get 1, you can get the square root of 3 over 3. You can get the square root of 3. You can get undefined. And you can get the negative values in here of these 3 in the middle. So remember that the square root of 3 over 3 is, this isn't written in order. It doesn't have to be, but it might help if you do write it in order from least to smallest. Square root of 3 over 3 is less than 1. So those are our possible values, and these could be plus or minus in the middle. And we also said that because sine over cosine of a particular angle is equal to the tangent of an angle, this is like our rise and our run. Remember I said sine is your y values on the unit circle and cosine is your x values, or your x distance, I guess you could say, from the origin. Then it's like saying our slope of that angle form, and you take a unit circle and you're talking about this line right here, this slope is the same thing as our rise sine over our run cosine, and sine over cosine's tangent, so therefore the slope of that line is also equivalent to your tangent. I'm going to use that fact today to help me figure out these real quickly. Now if you're timing me, you're saying, well, Mr. Burnett, you just took like 2 minutes just to explain everything written in red here. I'm explaining, I'm not actually trying to solve it as a time deal. So as we go through these, this is how I want you to start thinking about it. So you can do these 6 problems under 2 minutes, or maybe even under 30 seconds, depending on how quickly you become familiar with the unit circle. So 5 pi over 3, the first thing is to say, where is that angle 5 pi over 3? Well, I know it's bigger than pi because 3 pi over 3 is equal to pi right here. And so pi is right here. Notice 2 pi is all the way around the circle. If I put a 3 in the denominator, I'd have to make this 6 pi over 3 to be the same thing as 2 pi. So comparing 6 pi over 3 and 5 pi over 3, I know 5 pi over 3 is less than 6 pi over 3. And so how many pi over 3s am I away from it? I'm only 1 away from it, or the equivalent of 60 degrees. So I'm down here actually. Here's where 5 pi over 3 is. So that's the way I kind of quickly come up with it without actually going through drawing out the whole unit circle. The next thing I want to know is, what is the slope of that line? Well, here are my options. Is the slope of that line 0? No. Is it 1? No, because I know that when's the slope 1? It's when I'm talking about my pi over 4 angles. So when I have my pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, oh, not 6, 4, 6 pi over 4, 7 pi over 4. These are slopes of 1, so the tangents at these 2 angles is 1. This one's negative 1. So I know it's not 1. I know it's not 0. It's not undefined because it's not vertical. So it's going to either be square root of 3 over 3 or square root of 3. And I know it's going to be the negative version, but we'll talk about that in a second. So the question is it the steeper slope or the shallower slope when it comes to these angles right here? So this is like my 60-degree reference angle right there. And so 11 pi over 6 right here would be the other triangle. That would be a 30, 60, 90. So this one, 11 pi over 6, its tangent is the shallow one. This is the steeper one right here. So which slope represents a steeper one? Square root of 3 divided by 3, or the square root of 3? Well, it's going to be the square root of 3 because that's a larger number, so it's representing a steeper slope. Now because it's going downhill left or right, I know the slope is negative. So the tangent of 5 pi over 3 is going to be negative square root of 3. Next is the tangent of pi. So when I'm looking at that circle, let's sketch that one out. Let's see where I put it, right here. So the tangent of pi, that's a little bit easier to find on the angles wise. It's right here. So what's the slope of this line? Well, the slope of that line is 0. So that's my answer, 0. Tangent of pi is 0. Now this one we haven't really seen before, at least not since I've talked about coterminal angles. It's the tangent of negative pi over 3. And so negative angles, remember, go clockwise. So it's like we're taking this ray right here and I'm going to rotate it clockwise. And that goes in the negative direction. So I want to drop down pi over 3 amount, which is exactly what I did over here on number 1. In fact, negative pi over 3, whoops, thought I still had on my line tool here. Negative pi over 3 and 5 pi over 3 are coterminal angles. So they land in the exact same spot, and their answer is going to be the same as far as tangent goes. They both have the tangent of that angle is negative square root of 3. Next, let's look at 3 pi over 2. So sketch out the circle and find that angle. So where's 3 pi over 2? So here's 1 pi over 2, 2 pi over 2, 3 pi over 2. It's right here. So at this point, what is the slope of that vertical line there? Oh, it's a vertical line. They have slopes that are undefined. So our slope is undefined. Or tangent of 3 pi over 2 is undefined. 3 pi over 4. Well, I already marked it out over here on this circle. 3 pi over 4 is right here. 1 pi over 4, 2 pi over 4, 3 pi over 4. What's the slope of that line? The slope of that line is negative 1. Notice it goes downhill, so it is a slope of 1 on those 45, 45, 90 triangles, but since it's going downhill, it's going to be negative 1. And if you're wondering, like, how is he getting the slope? What's going on here? Remember your triangle that's formed right in here. That triangle has side lengths that are negative square root of 2 over 2 and positive square root of 2 over 2 right here. I say negative because you're going in the negative direction on the x-axis. So if you come up with that slope, remember the slope is rise over run. So if I'm right here, I would have to rise up square root of 2 over 2, and then I'd have to run in the negative direction a negative square root of 2 over 2 to go from this point to this point. So my rise over my run is this, square root of 2 over 2 divided by negative square root of 2 over 2, which gives me negative 1. So I'm putting my sine over my cosine. Notice this is my sine value. This is my cosine value. And sine over cosine gives me tangent. So same thing as slope is putting sine over cosine when you're talking about the unit circle in these values. So that's how we got this one right there. Next one, 11 pi over 6. Where is 11 pi over 6? Let's sketch out the circle. Got a lot of circles going on right here, but I'll draw one more in. 11 pi over 6 is really close to 12 pi over 6. Think about it. What is 12 pi over 6 equal to? 12 pi over 6 is the same thing as 2 pi. So going all the way around the circle is 2 pi, or 12 pi over 6. I'll try to fit in there. It's going to run off your screen. 12 pi over 6. And then 11 pi over 6 is just 1 pi over 6 short of that. So it's this triangle right here, the shallower slope right there. So it's smaller than 1 because 1 is our 45, 45, 90 triangle on that quadrant. But it's less than square root of 3 because that's the one we've been talking about over here with negative pi over 3 and 5 pi over 3. It's that angle. This angle is the steeper one. And then you've got the 45, 45, 90 coming in like this. I want to know what is the slope of that line. So it's going to be the shallower one. And because it's going downhill also, it's going to be negative square root of 3 over 3. Oop, that's not in blue. It's not helpful for people that just skip ahead and see the answers, right? So negative square root of 3 over 3. I'm not talking about you folks in my class. I know you don't do it. I'm talking about the other 28 followers I have on YouTube. All right, so hopefully that little bit of practice helps you with tangent. Go back and look at the video I showed the video prior to this one for a little bit of practice with sine and cosine. And maybe I'll make a video later where we bring it all together and we do just a bunch of practice problems. But for now, I want you to take each day and work on little parts of the unit circle, whether it be finding the angles if you're still struggling with that, or finding sine, cosine, and tangent. But very soon, in the next day or two, you're going to get a quiz on doing any of this. And I'm going to have it timed. So you got to have it down so that you can do it quickly. So take your time. Even though I'm not assigning you practice, take the time each day and spend 10 or 15 minutes picking out, get out your unit circle, pick out about 5 different angles, maybe 6 different angles, and quickly come up with the sine, cosine, and tangent of each one, and then check it. All right? Well, today we're going to start a different topic, and that is we're going to add 3 more trig ratios to the mix here. So far, if you go back to geometry class, I like to tell my students, as I said in the other videos, to memorize, Oscar had a heap of apples. And then look on their calculators and say, this is the sine of theta, this is the cosine of theta, and this is the tangent of theta. And the reason why I like for them to see it written out like this is because the fraction's already set up for you. And I give them this theta right here because theta is just weird. And I want them to remember that theta is an angle. So you're always putting an angle in for theta. It's never anything else. It's always an angle on these trig functions. And then from there, you got your equation set up. And a lot of times in geometry, we'll give you either opposite hypotenuse, one of those 2 sides, or 2 of those sides, and the angle. There's only 3 variables here. You solve for one of them, we give you 2. Or we give you more information than that. Or you got to use Pythagorean theorem to find out one of them. But really, it's just dealing with 3 variables, and only one's unknown. So we're going to take this a step further today, and we're going to say, what if we were to flip these fractions? So, for instance, right here I have opposite over hypotenuse. I'm going to flip it and get hypotenuse over opposite. And so I'm going to flip this one and get hypotenuse over adjacent. And then I'm going to flip this one and I get adjacent over opposite. So these are what we call, remember when we flip a fraction, a fancy math word for it is to take the reciprocal of it. And that's where we get these reciprocal ratios. And they have special names also. So those names are cosecant, secant, and cotangent. And so just be careful here. Some people always want to pair up sine with secant and cosine with cosecant. That's not what's going on. Remember, S always pairs with C. Okay, when we're talking about reciprocals, C pairs with S, and nobody gets cotangent mixed up with one of the other 2. It's always these 2 that get mixed up. So C always pairs with S, S pairs with C, and you won't forget which one you're flipping there. So in the very basic type of problem I could give you, I could say, suppose the sine of theta is equal to 3/4. What is the cosecant of theta then? So the cosecant of theta, it would just be the reciprocal then. If theta is the same here in the same problem, it'd be 4/3. So you're just flipping it there. Okay? Sometimes they get a little bit fancy with these and they say, all right, that's too easy. These students are pretty bright. Let's throw something at them. And let's put in theta. So there's our theta. This is a right triangle. And they tell us that the tangent of this is, say, tangent of theta is equal to the square root of 2 over, 3. So if the tangent is the square root of 2 over 3, what is the secant of theta equal to? So you say, okay, the secant of theta, and where's the secant? The secant of theta is hypotenuse over adjacent. Well, tangent theta, here's my theta. Let's label our chart here. Tangent of theta is the square root of 2 over 3. I know tangent is opposite over adjacent. So the opposite side of theta must be the square root of 2, or at least reduces the square root of 2 when we put the numbers in. But I know that the ratio of the sides, the opposite over adjacent, is the square root of 2, and the adjacent side would be 3. Maybe it's 5 times as big as square root of 2. and this side length is 15 down here, but when I reduce it, this is what I get, square root of 2 over 3. What would be the corresponding hypotenuse then? So this takes us back to Pythagoras. So let's use Pythagoras' model and say 3 squared plus the square root of 2 squared equals the hypotenuse squared. So this becomes 9 plus 2 equals c squared, or 11 is equal to c squared, so the square root of 11 is equal to c. And so now we can think of, what do we ask for? The secant here. And so a lot of times when I'm thinking these, I don't have this always written out, what's written in green here. I just have this in mind. I say, well, what's my step in between to say, what is the cosine of theta? Well, the cosine is the adjacent over the hypotenuse. And before I reduce anything or rationalize anything, I go ahead, I know I'm going to flip it, so why rationalize it when I'm going to flip it anyway? So I'll go ahead and flip it now. So that means the secant of theta is equal to the square root of 11 over 3. And that's my answer. All right. So hopefully that makes sense. We'll see a bunch of examples with that in today's assignment. All right. So here is a preview of the work you have to do today. I want you to do all of it. I'll kind of go through this slowly. So maybe if you're not in my class and you're just watching this and you want to try out some problems, there you go. There you go. Oh, it's not a blur when you pause it. But I'm going to work through a few of these right now. Looking for secant. Sometimes we want to find cosecant. So when I go to find cosecant of theta, I say, well, first I need to figure out what is the reciprocal of cosecant. Reciprocal of cosecant is the sine of theta. And so that's what I want to figure out here. And once again, I need to know opposite over hypotenuse. So I need to know the hypotenuse again. That takes us back to Pythagoras once again. So we got 8 squared plus 16 square roots of 2 quantity squared equals c squared. And so 8 squared is 64 plus 16 squared, which I believe is 256, times square root of 2 squared, which is just 2, and 256 doubled is going to be 512, and add 64 to this, so we get 576. And off the top of my head, I don't know if that's a number. Let's see. Alexa, what's the square root of 576?
The square root of 576 is 24.
Oh, it's 24. What do you know? So there we go. So this right here is 24. And we're going to say, okay, we've got opposite over hypotenuse. This is theta. That's opposite. So 16 square roots of 2 over the hypotenuse of 24. Oh, that I reduce. Once here, 8 will go into both of those. So we get 2 square roots of 2 over 3. And then we're going to flip that thing for cosecant. So the cosecant of theta equals 3 divided by 2 square roots of 2. Let's rationalize that thing. Square root of 2 over square root of 2. That gives me 3 square roots of 2 over 4. Because the square root of 2 times the square root of 2 is 2. And 2 times 2 is 4. So 3 square roots of 2 over 4 is my answer there. So all I'm doing is finding the reciprocal and then flipping that thing. Next, cotangent of theta. Pause the video and give this a try if you haven't yet. Alright, so we're going to take 25 and square it. So for cotangent, I need to know tangent, and then I'm going to flip it. Tangent involves finding the opposite over adjacent. Here's my theta. That's opposite. This is adjacent. It's unknown. I'll call it x. And so once again, turn to Pythagoras, and we're going to get x squared plus 15 squared equals 25 squared. 25 squared is 625. 15 squared is 225. So I get x squared is equal to 400, where x is equal to 20. So that means my opposite over adjacent is 15 over 20, which is the same thing as 3 over 4 when you reduce it. So flipping that, I'll get cotangent. So cotangent of theta is equal to 4/3. Now, while we're here, this is a bonus if you're actually following along with me and not just skipping to the homework. Not really a bonus, but required stuff to know. We say that the sine of theta is equal to opposite over hypotenuse, and so therefore the cosecant of theta is that flipped, or hypotenuse over opposite. But you don't always have to write it out like that or think of it like that. We could write an equation as this, relating the two. The sine of theta is equal to 1 over the cosecant of theta. Likewise, we can say that the cosecant of theta is equal to 1 over the sine of theta. And so we can rewrite it like that as well. And that should make sense, because if I'm talking about the sine of theta, we do know that the sine of theta equals opposite over hypotenuse. Well, the sine of theta, if it's equal to 1 over cosecant, and cosecant equals hypotenuse over opposite, I could rewrite it like this. Now, this is the number 1 being divided by this fraction right here, hypotenuse over opposite. So if I make that a fraction, 1 over 1, I get a fraction divided by a fraction. And let's simplify that. So we keep the first fraction, we flip this division to multiplication, and then we switch from division to multiplication, and then we flip this one right here, so it becomes O over H, and then multiply straight across, you get sine is equal to opposite over hypotenuse. So it just kind of shows you we can rewrite sine as 1 over cosecant. You're going to see that a bunch. Or you can write cosecant as 1 over sine. It doesn't work only for that. Let's go and write them all out. You can say what we just said, just in case somebody is skipping along in the video and they see this page and they're like, wait a minute, something's important on that. You stop doing problems. We can say, let's get the pen tool here. So we can say what we just said. Let's go ahead and write that out. The sine of theta is equal to 1 over cosecant. You can say that the cosine of theta is equal to 1 over the secant. And you can say that the tangent of theta is equal to 1 over cotangent. And we can go the other way. Notice if we multiply both sides by cosecant and divide both sides by sine, we'd get the cosecant of theta is equal to 1 over sine. The secant of theta is equal to 1 over cosine. And that the cotangent of theta is equal to 1 over tangent of theta. So you can define them like that. You can define them like we did before. We say opposite over hypotenuse, hypotenuse over opposite. You'll see them written out both ways. You'll have to use recall both ways for different types of problems. So just keep that in mind. All right, and this one doesn't have a picture drawn for us. We're skipping down, by the way, to number 25 here. They say if the tangent is 3/4, what is the cosecant? And we're assuming that all of these are right triangles right now. We haven't put this on the unit circle yet. But we've got theta right here. The tangent, which stands for opposite over adjacent, is 3/4. So this side would be 3, this would be 4. Not necessarily, once again, that that's the side length, but the ratio of this side to this side is 3 over 4. So using Pythagorean theorem, we can figure out what the hypotenuse would be, and that comes out to be 5. And then so when I see cosecant, I think, oh, the reciprocal is sine of theta. So what's the sine of theta right here? The sine is opposite over hypotenuse, or 3/5. So the cosecant is going to be flipping that, so the cosecant of theta becomes 5/3. Next one, it says find the cotangent if the secant of theta is equal to 2. So when I see secant, I think, okay, what's the cosine then? This is 2 over 1. Cosine is 1 over 2. So looking at my triangle here, here's theta. And so cosine is adjacent over hypotenuse. And so I want to know what cotangent is. Well, I know that tangent is equal to opposite over adjacent, and cotangent is going to be what? flipping that so it's adjacent over opposite. So I need to know what that opposite side is. So I'm going to call it x and use Pythagoras. So 1 squared plus x squared equals 2 squared. So 1 plus x squared is equal to 4, or x squared is equal to 3. X equals the square root of 3. So this is the opposite side, adjacent, and this is hypotenuse. I want to know adjacent over hypotenuse, so it's going to be 1 over the square root of 3. So the cotangent of theta equals 1 over the square root of 3. Rationalize that denominator, and you get cotangent of theta equals the square root of 3 over 3. There you are. All right, next says, and this is number 29, find the secant of theta if the sine of theta is 3 square root of 13 over 13. Let's, once again, stay in the world of triangles for now. And let's see, 3 times the square root of 13 over 13. I know that sine is opposite over hypotenuse, so this is 13. I'll call this angle theta. This right here is going to be 3 square roots of 13. And so I want to know what the secant is. The secant is the reciprocal of cosine. And cosine is the same thing as adjacent over hypotenuse. So I need to figure out what this adjacent side is. I'll call it x and use Pythagorean theorem again. So I'm going to get 13 squared is equal to 3 square roots of 13 quantity squared plus x squared. I know that square root of 13 squared is just 13. 3 squared is 9. 13 squared is 169. 9 times 13 is 90 plus, what, 27. It's going to be 117. And so I'm going to get 100, and at 100, just 52 is equal to x squared. So x is equal to the square root of 52. And so if the cosine of theta is adjacent over hypotenuse, I get square root of 52 over 13. That means the secant of theta will be that guy's reciprocal, or 13 over the square root of 52. And then rationalizing the denominator, I'm going to get 13 square root of 52 over 52. And just to make sure, I'm just going to say 52 breaks down into 2 and 26. 26 breaks down into 2 and 13. So I could say I've got a 2 that can come out of this. Just to make it look a little prettier, we can say it's 26 square roots of 13 over 52. Hey, 26 is half of 52. And so all of this reduces to square root of 13 over 2. So the secant of theta is my final answer here. Secant of theta equals the square root of 13 over 2. All right, that's all I got for you. Let me pull up the answers and I'll show it to you here on the video real fast so you can check your work. And once again, what I'm going to do is I'm going to just kind of scroll through this slowly, because I know when you pause, if I'm moving like this, when you pause, it's going to just be a blur. So I'll just scroll it down and pause for a moment.